Hello students, I shall discuss the concept of shear force and bending moment diagram, SFD and BMD. Shear force is nothing but the vertical unbalanced force acting on a beam. Let us take an example of cantilever beam AB with point load P and a span of length L. Now let us try to plot the shear force and bending moment diagram for this cantilever beam. Let us take a section 1-1 at a distance x from free end B. Shear force at section 1-1, section right, I am considering downward force as negative, so the shear force will be equal to minus P. The section is valid from B to A, so shear force at B is equal to minus P, shear force at A is equal to minus P. So let us try to plot the shear force diagram AB. At A it is minus P, at B it is minus P, and the degree of this equation of shear force is 1, so it will be joined by a straight line. So this is P and this is minus. So in this way we can plot the shear force diagram. Now let us see with the same section how we can plot bending moment diagram. Bending moment diagram, bending moment is nothing but force into distance. So M11, which represents the equation for bending moment, so this is clockwise, section right, I am considering negative. You can consider positive also, it will not make any difference in the solution. So moment is minus P into X, section is valid from B to A, the distance is 0 to L. If section will remain at B, it will be x equal to 0, and if it is going at A, it will be equal to L. So moment at B when x will be equal to 0, it is 0. Moment at A when x will be equal to L, we will get minus PL. So let us try to plot the bending moment diagram for this cantilever beam. So this is A, this is B, span is L. At free end B the moment is 0, at this it is minus PL, so we will show this value below this x-axis, so it is PL. The degree of this equation of bending moment is in the order 1, so we will join it by a straight line. So this is your bending moment diagram. So basically this shear force diagram and bending moment diagrams, when we plot, these are very helpful in designing of the structures. For example, we are getting the value of bending moment PL. In actual structure, when we are designing cantilever beam, we have to take this value of bending moment diagram. Maximum value of from this bending moment diagram is PL, and then we have to design steel reinforcement. So for providing steel reinforcement in beam, we have to plot first of all the bending moment diagram. Next, the significance of shear force diagram. In beam, if we want to design stirrups, then we should know the maximum shear force which is being developed in this beam due to loads. So this shear force diagram, we will get the maximum value and we can design stirrups. So designing of any beam, we need SFD and BMD both. From those values only we can provide steel and stirrups within the beam body. Let us take an example of simply supported beam. This is simply supported beam with span L and ends AB with point load is acting at mid. Now first of all we have to evaluate the reactions. This is RA and RB. If we want to plot the SFD BMD for this beam, then first of all reactions are to be evaluated. So reactions we can evaluate by Varignon theorem or by applying the equations of equilibrium. summation of fx equal to 0, fy equal to 0, but we don't need that. Ra, Rb, we can directly p by 2 will be the reactions, and by this section method we can plot the SFD BMD, we can provide reinforcement, and we can decide the dimensions of the beam to design this simply supported beam. Thank you very much.